Welcome to Chemistry Concept, and now let's discuss about galvanic cells. And we know the galvanic cells are nothing but electrochemical cells which convert the energy of spontaneous redox reaction into electrical energy. And let's have the example of one galvanic cell which is made up of zinc and copper, and this is the redox reaction involved in that, and that cell is known as Daniell cell, which is a type of galvanic cell, and it is like this. We have two half cells, one is anode, another is cathode. In one we have ZnSO4 solution, in another one we have CuSO4 solution. Okay, and in one we have zinc rod dipped, that is zinc. Another one we have copper rod dipped. Zinc rod or zinc electrode in zinc sulfate, copper electrode in copper sulfate, and the two half cells are connected through salt bridge. This is the setup actually. Okay, at anode oxidation takes place, at cathode reduction takes place. Now what oxidation, what reduction here? See, this is the overall reaction. This is called cell reaction. Okay, in this is actually oxidation half reaction, and this one, copper iron to copper, is actually reduction half reaction. This oxidation half reaction takes place at anode and this takes place at cathode. Okay, and there is a formula to remember this: LOAN. On left side, that is left, oxidation takes place, and that is known as anode, and that is negative in sign. Okay, so this was the cell, actually a typical galvanic cell, which is also known as Daniell cell. And now the next thing is cell representation. So there are two things: cell reaction, oxidation half reaction, reduction half reaction. Next thing is cell representation. How we represent? On the left side we write anode, and at anode zinc is getting converted into zinc 2 positive. Zinc was solid, zinc 2 positive was from zinc sulfate, that is aqueous, separated by a salt bridge. Then we have copper 2 positive in aqueous form getting converted into copper solid. So this is how we represent a cell. Anode, on right side cathode, represented by two separated by two vertical lines, which is nothing but salt bridge, and the function of salt bridge is to complete the circuit actually, and to actually maintain the neutrality by transfer of ions. Transfer of electron takes place through external circuit, and ions are transferred through the salt bridge to maintain the electrical neutrality. Now there is another thing which is known as cell potential. Now every electrode has some potential, and that is which you can see from the electrochemical series, and here all the standard reduction potential values are given. Okay, so see, for one was over zinc 2 positive 1, another was over copper 2 positive to copper 1. For this zinc electrode, the value given is minus 0. E naught cell is minus 0.7627. Okay, and for copper 1, the electrode potential is plus 0.337. Let me tell you one thing, these all are reduction values, and as per IUPAC we follow standard reduction values only. We always take standard reduction potential. If it is given as standard oxidation potential, first convert it into standard reduction potential by just changing the sign. If it is positive, it will become negative. So it is given here. So from this, for both the half cells, like the one was zinc to zinc 2 positive, the potential value is minus 0.76. For copper 2 positive and copper, the value is plus 0.337. The one which has more negative value will be at anode, will undergo oxidation. Okay, so now we know the half electrode potential, the potential of zinc electrode, that is anode potential for Daniell cell, is minus 0.76, cathode potential is 0. Plus 0.337. Now what is the potential of overall cell? That is given by, if I want to know the cell potential, that would be standard reduction potential of cathode minus standard reduction potential of anode. Okay, for cathode, that means Z naught cathode was copper 2 positive to copper 1, and anode is, yes, zinc 2 positive to zinc 1. Actually it is 2 positive here. Okay, fine. And the values are, for copper 1 the value is 0.337, it is minus. For our zinc 1 the value is 0.744. Solving, the value comes out to be 1.1 volt almost. Fine. So this is how we find out the standard cell potential. If we know the standard cathode potential, standard anode potentials, so these are cathode potential and anode potential are standard electrode potential. The difference between the standard electrode potential is known as standard cell potential.